Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 7 of a unit motion in a plane. So let's begin with today's class. In today's class we are going to discuss about the projectile motion. This is the part 3 of a projectile motion. In the previous units we have derived some of the relations. Let's have a look and move with the next applications of the projectile motion. So here it is the formula list, that what the situation is that we have projectile object with speed u while making an angle theta with the horizontal. The time of flight, it's a 2u sine theta by g. H max, it's a maximum height, it is a u square sine square theta by 2g. Range, it is the u square sine 2 theta by g. Equation of trajectory y, that is equals to x tan theta minus of half into gx square into u square cos square theta. So these are the certain formulas. These are the certain formulas that we have derived and we have used it. Now let's begin with the today's applications, some advanced applications of the projectile motion. So let's have a look. Have your pen and paper ready, and please don't just watch this video, please make it with me. Yes, please solve the questions. When a question would be there, you need to just pause the video, try to attempt those questions and try to get an answer. If not, I would be there to solve for you, but you need to at least attempt it. Yes, so let's begin with today's class. The question is prove that equation of trajectory can be written as y is equals to x tan theta into bracket 1 minus x by r. You know all the symbols. Yes, r stands for range, y is for y-axis, x is for x-axis. So I need to prove that my equation of trajectory can be also written such as y is equals to x tan theta into bracket 1 minus x by r. How should I do this? So before I begin, what is my relation of equation of trajectory? Have you remembered this? Have you remembered the formula of equation of trajectory? It is y is equals to x tan theta minus of half into gx square divided by u square cos square theta. This is the relation. This is the relation that we are using just now. If you have remembered this, yes, this was the relation. Yes, and I need that it should look like something like this. So how should I do this? So let's try it something like this, that I multiply and I divide the relation with tan theta. Now what happens when cos square theta and tan theta has been multiplied? So if I make a rough work, it's a cos square theta into tan theta. That tan theta can be written as sin theta by cos theta. Yes, so this is cos square theta into tan theta, cos square theta into tan theta. This cos theta gone, and the term remain is cos theta sin theta. So that should look like it's an x tan theta minus of half into gx square into tan theta divided by u square into cos square theta into tan theta. That will look like cos theta into sin theta. So this is the situation, it's in cos theta into sin theta. Now if I make an x tan theta as in common, then x tan theta into bracket here 1 minus of, here what terms has been remained, it's an x tan theta has been taken as a common, it's in 1 by 2 multiplied by g multiplied by x square, x is here, it's an x divide by it is a u square into sin theta into cos theta. So this is the term. Let me rewrite this. The relation is y is equals to x tan theta into bracket 1 minus half g into x divide by u square sin theta cos theta, u square sin theta into cos theta. Now look at this carefully. It's a 2 into u square into sin theta into cos theta divided by g. What is it? What is your range? Range is u square sin 2 theta divided by g. It's a u square multiplied by 2 multiplied by sin theta multiplied by cos theta divided by g. Yes, so this is the same, 2 into u square into sin theta into cos theta divided by g. So this would be y is equals to x tan theta into bracket 1 minus x divided by r. That's it. We have proved it, that y is equals to x tan theta into bracket 1 minus x by r. Yes, where r represents the range. Yes, please remember this. This is the new form. This is the new form of equation of trajectory. This is the new form of equation of trajectory. But many questions are there. Which can be solved very easily if I know this relation. Want to see this? Let's have a look. Let's understand the question first. What the question is demanding from us. That let's say that this is the x-axis, this is the y-axis, and a certain object is there. It has been projectile by this with an angle theta with a speed u. Now what the data says, that an object is there which has been thrown with angle theta while speed u, and at certain distance from the projection. Let's assume that distance as an x1. At a certain distance from a projection, a pole is there. The height of that pole is h. That the pole is there, and the distance from that pole from the point of projection is x1. My projectile just passed through it, and it is reaching to the distance x2 from the pole P. I need to find out height of the pole. This is what they require. Now in situations somewhere a student gets stuck that this must be the maximum height, but this is not the case. Maximum height would be at this point, na? Yes, this is not the case of maximum height as well. So what you can do is just write down the relation y is equals to x tan theta into bracket 1 minus x by r. Now if I am talking about this coordinates, their y coordinates, if I am talking about this coordinates, their y coordinates is the height h. That is equals to, if I am talking about this coordinates, my x coordinates represents the x1. It's an h is equals to x1 into bracket tan theta into bracket 1 minus x coordinate. It's an x1 divided by range. Look at the diagram. What is range? It's a maximum horizontal distance. So this is x1 plus x2. So this is equals to x1 tan theta into bracket x1 plus x2 minus of x1 divided by x1 plus x2. If I solve this 2 has gone. So what I can have, it's an h that should be is equals to x1 into x2. This is equals to x1 x2 divided by x1 plus x2 multiplied by tan theta. This is what I require. Yes. So can you do this? A very good applications. Many questions can be solved using this. it's in y is equals to, please remember this, y is equals to x tan theta into bracket 1 minus x by r. Please remember this, please. Very good application. Yes. So can you do this? Great. Next. The question is, if x is equals to 80 and y is equals to let's say ct minus of dt square, find out angle of projection. Yes, this is only they have told us that if x equals to 80 and y is equals to ct minus dt square, then find out angle of projection. So what I understood is that, let's say this is x, this is y. Suppose I have make a projection like this, then this must be the velocity u and this must be the angle. So what I considered, it's a tan theta, that is this is ux and this must be the uy. I'm talking about the u stands for initial, that you know. So my tan theta should be is equals to u of y divided by u of x. Here I am available with the x, and what I want a velocity. So I am having x and y, but I require a velocity. So if x is there and velocity is required, x is equals to 80. If I differentiate this, I can have an ux. So ux, which is equals to dx by dt, that would be equals to d by dt of a into t, which will give me an a. I hope this is clear. Now let's turn for the y. The y is given as y is equals to ct minus of dt square. So this is dy by dt, which is equals to v of y. That would be equals to d by dt of ct. You know this is a c minus of 2 dt. Yes, but you don't require velocity at any time. You require velocity at the time of projection. That means at t is equals to 0. At t is equals to 0, uy equals to c. So now you require a tan theta. How could I get it? So I know that tan theta is equals to uy divided by ux. This is uy divided by ux. My uy is c, ux is a. That's it. Done. You did it. Great job. Do you understand this? Yes. Do you understand this? Can it be done by you people? Are you sure? Can it be? Let's move to the next question. Do it quickly. Do you enjoy this? Yes. Let's begin. Suppose they have given that velocity vector is given such as it is 4i plus 2j. Find out range of projectile. Yes, that's it. They also say you can take g is equals to 10 meter per second square. This is what they have provided. So how can you do this? This is just simply they have provided this data only. V is equals to 4i plus 2j. No theta, no angle, no velocity, and nothing. Yes. So how could I get it? Any idea? So what I assume is that V is equals to 4i plus 2j. Yes. So what I can write is that this is the Vxi plus this should be the Vyj. So I have been provided Vx, which is equals to 4, and maybe I have been provided Vy, and it is not related with the time anywhere. So this is Uy, that is equals to 2. Now what is range? What is range? What I can know is that range is equals to 2 into u cos theta into u sin theta divide by g. Can I write this? Yes, it is the same thing, u square into 2 into sin theta into cos theta by g. So I can write like this, it's a 2 into ux into uy divided by g. So this is 2 multiplied by, they have provided me the ux. Vx and ux are the same because velocity in horizontal direction remains the same throughout the journey. So this is 2 multiplied by 4 multiplied by 2 divided by 10. This is 2 5s are 10. This is 2 4s are 8. 8 by 5. This is 1.6 meter. And that's it. You did it. Yes. Yes. So can you do this? Yes. Please remember this. This is very very important. Range is equals to 2 multiplied by ux into uy divided by g. This is range. Range is equals to 2 into ux into uy by g. I hope this is clear to you. Is it? Is it? So, ready for the new question? Let's have a look. The new question is that suppose a projectile is given such as like this. This is velocity u, this is velocity theta. Yes, they have projected this at two different situations, let's say, or I can say two different locations. Here their velocity is 20 meter per second, and here the projection, that means angle, is 30 degree. When this projectile is available at here, if I make an horizontal, it is something like this. This is 45 degree and I want to find out a velocity at here. So the question is, find out velocity v at point P, and this is point P. So how can I do this? Any idea? Just pause this video and try to do it. If you cannot, let's have a look. Do you know that velocity, or I should say a horizontal component of velocity remains same throughout the journey? Yes, do you know this? That horizontal component of velocity remains the same throughout the journey. So what I can write is, at this point it's a v1 cos theta. Let's write this as a v2. It's a v2 cos 45. So if I write this v1 cos 30 degree, that should be is equals to v2 cos 45 degree. My v1 is, it's a 20 that has been given from the data. It's a 20 into cos 30. This cos 30 would be equals to root 3 by 2. This is root 3 by 2. That should be is equals to v2 into cos 45. It's a 1 by root 2. Yes. So What I can do is, it's a 20, it's a 2, this is 10. So V2 is equals to 10 multiplied by root of 3 multiplied by root of 2, which is 10 root 6 meter per second. That's it. You did it. I hope this is clear. Is it? Is it clear? Can you do this? Are you sure? Can it be done? Can it be? Great. Let's move to the next question. Suppose the question is, find out time at which initial velocity vector, let's say v1, and velocity at that time, let's call it as a v2, is perpendicular to each other. This is very beautiful question, very logical question, very beautiful, as it covers multiple concepts in a single and straightforward question. I like this. So you just go through once, twice, thrice, 5 times, 6 times, 10 times, and try to find it out the way that I want a certain particular time at which velocity, it's a v2, and initial velocity vector, that is v1, is perpendicular to each other. How should I do this? How it can be done? First, let's assume that what they are probably wanting from us. This is the projectile, and this is the initial velocity vector. This is, let's say, angle theta, and this is v1. Now let us assume that a certain time would be there, and that time a certain velocity vector would be there. This is velocity vector v2, let's say, and this velocity vector and this velocity vector must be perpendicular to each other. That is what they require. They want this time, they want the time so that v1 and v2 must be perpendicular to each other. This is what they require. So how could I do this? How could I do this? Yes. So let me first guide you. First, write down the velocity vector v1. What is it? So if I understood v1 well, what I understood is that it's a horizontal component, it is u cos theta, and its vertical component, it is u sin theta. Yes. So v1 should be is equals to u cos theta I cap plus u sin theta j cap. Now write down the v2. It would be again having a 2 component. It's an u cos theta I, because velocity in x direction never changes, but this is vy na, this is u sin theta minus of gt, this is j cap, because it is in y direction. I hope this is clear. Is it clear? Yes. So this is v1, this is v2. Now I know that my v1 and v2, these two are perpendicular to each other. So if these two vectors are perpendicular to each other, I can make the dot product, and that dot product would result in a 0. So look what I am supposed to do. It's a v1 dot v2. So what I am going to do is, it's a v1 dot v2, which will give me an v1 v2 cos 90 degree, and my cos 90 should be a 0. So this is 0. My v1 was Shall I rewrite? Shall I? Let's have a look. It's a u cos theta I cap plus u sin theta j cap v2. It's a u cos theta I cap plus u sin theta minus of gt j cap, and I need to multiply this. That means I need to provide a dot product of this two. In dot product, what we are supposed to do, we are just multiply I cap with I cap and j cap with j cap. That's it. So when I do this, what I'm going to have is that v1 dot v2, that is equals to, it's a u cos theta multiplied by u cos theta. This is u square cos square theta plus this is u sin theta and this is u sin theta. This is u square sin square theta, u sin theta multiplied by gt. So this is multiplied by u sin theta into gt, and that would be equals to 0. So if I just pick this one, u square cos square theta plus u square sin square theta, so this is u square into bracket cos square theta plus sin square theta, that should be is equals to u sin theta multiplied by gt. Yes, so this is cos square theta plus sin square theta, which will be 1. It's a u square into bracket 1 should be is equals to u sin theta into gt. This u and this u would be a gone, and only the term remain, that is the I required a time. This time would be equals to u divided by g sin theta. That's it. Please remember this. This t at time t is equals to u by g sin theta. At time t is equals to u by g sin theta. The velocity vector v2 and the velocity vector v1 are perpendicular to each other. Yes. Please remember this. Please. This is very essential. Yes, and this is one of the favorite question of examiner. Yes. So shall I add something to this? May I? Let's have a look. In previous question, find out velocity at time t. Yes, this is what they require. In previous question, find out velocity at time t. So what can you do? This was the situation. This was my vector v1. This was my vector v2. This was the angle theta. This was the 90 degree as the data suggests. And so if this is theta, this is 90 degree. So that should be a 90 minus of theta. That you understand. It's a three sides of triangle. Yes, should edit will make a 180 degree. So if this is 90 minus theta, even this must make a 90 minus theta. This is v2. This is v2 cos 90 minus of theta. This is v1 cos theta. Yes, we have this previously as well, that what horizontal component velocity will remain the same. Yes, so what can I do? When the velocity, or when I should say it's an horizontal velocity, remains the same. So what I can have is v1 cos theta should be is equals to v2 cos 90 minus theta. This v2 cos 90 minus theta, it is a sin theta, into v1 cos theta. So this v2 should be is equals to v1 cos theta divided by sin theta, and cos by sin, it's a cot. So this is v1 cot theta. Yes, V2 is equals to V1 cos theta, or cot theta, sorry, I made a mistake. It's cot theta. Yes, V2 is equals to V1 cot theta. Yes. Yes. So did you enjoy this bundle? Yes. A bundle of two questions. They are related with each other. Yes. So interested in doing the same thing for just a practice purpose? Yes. So let's have a look. This is velocity v1, and let's say that this is velocity v2. This is 30 degree, this is 90 degree. This velocity v1 is 30 meter per second. They ask that find out time at which v1 and v2 are perpendicular to each other. So at this point of time you are just going to use the formula and not going to derive this again. This t is equals to u divided by g sine theta. U is the 30, g is the 10, sine theta, it's a sine 30, it's in half. So this is 5 and this will happen at 6 seconds. That's it, you did it. Great job guys. Yes. So directly apply the application. Because these are the questions which takes a certain amount of time to be solved. Yes, and probably we cannot afford that amount of time in the examinations. Yes, so according to me you need to remember this kind of applications, and there is nothing wrong in that to remember certain applications. Yes, so please, I'm trying to cover as many applications as I can. Yes, so but if I am trying from my side, you must remember it from your side. Yes, this will create a good result for us, for you, for me, for both. Yes, so let's move to the next question. The question says, if velocity at maximum height is half of the initial velocity find out range. Yes, this is what they require. If velocity at maximum height is half of the initial velocity, find out the range. How should I do this? Let's have a first sketch of this, what they want. This is the velocity at maximum height. What is it? Yes, at this point Vy would be a 0, but Vx would be there, and Vx would be a u cos theta. Vx would be a u cos theta, and this velocity, it is a u. Yes, initial velocity would be. So what they want? They want from us is velocity at maximum height. That means u cos theta is half of the initial velocity. So this is u by 2. This u has been gone, and cos theta is equals to half. As cos theta is equals to half, that means theta is equals to 60 degree. Now you need to find out the range. So range can be written as 2 multiplied by u square multiplied by cos 60 multiplied by sin 60 divided by g. That's it.
It's a 2 multiplied by u square into cos 60, it's a half, sin 60, it's a root of 3 by 2 divided by g, it's a 10. Yes, this 2 gone, so that should be is equals to root 3 by 2 into 10, it's a 20 to u square. This is what they require. It is as simple as that. Yes. So what was your answer? Is it even close to similar? Yes. Is it? Does it? Great. Great job. If you have been landed on the same answer, well done. Ready for the next question? Are you ready? Let's look at the next question. Suppose the situation is, let's say something like this, that this is u, this is theta, and this is 0.1, this at the maximum height, this is 0.2. They want that. Find out average velocity for journey of 0.1 to 0.2. That's it. This is what they require. Find out the average velocity for journey of 0.1 to 0.2. That's it. 0.2 is at maximum height, that you can see, and 0.1 it is the point which is at the point of projection, and you require the average velocity for this journey. How should I any idea that what can be done? So let's write down the velocity at 1.1. it's in v1, that would be equals to u cos theta I cap plus u sin theta j cap. At this point, velocity 2, which is u cos theta I cap, because at point 2 vy is 0, at point 2 vy is 0. So now what can be done? What we can supposed to do is this v average is equals to v1 plus v2 divided by 2. My v1 would be equals to u cos, this is v average, that you know, u cos theta I plus u sin theta j plus, even I am going to write this, u cos theta I divide by 2. So this is u cos theta plus u cos theta, this is 2u cos theta I cap plus u sin theta j cap divide by 2. This is v average, but again it's in vector component of v average. So if I want the magnitude of this, this was the v average. It's a 2 into u into cos theta I cap plus u sin theta j cap divide by 2. So if I take a magnitude of this, it's in v average, that would be equals to square root of this, because this is first vector in I cap, something like this. This is second vector, it's a vector number 2. Yes, so this is vector number 1, this is vector number 2, and angle between this two, it's 90 degrees. So this is 4 into u square into cos square theta plus u square sin square theta divide by 2 would remain as it is. Yes, this is u square, this is u square, keep it out of the square root, let's say u by 2. Let's break this under root of 4 cos square theta into two parts. One is the cos square theta plus sin square theta plus 3 cos square theta So is it okay? It's a 3 cos square theta plus cos square theta, which is 4 cos square theta, that I already written. So now it's in V average. It's in V average. It's in magnitude of this is equals to U by 2 cos square theta plus sin square theta. It's a 1 plus 3 cos square theta. This is it. This would be the final answer. Yes. So do you understand all this? Do you understand? Okay, one more thing. Do you enjoy this? Yes. So as many questions and as many applications you will go through, you will love it. Yes. In physics, you need to apply your brain because every question is different. Every question is different. Every approach is different. So you need to find out that which path can lead to my answer. Yes, and I need to choose that one. That would be the correct path. I hope you understand this. Is it? Is it? Yes. So shall we move to the next question? Are you sure? Shall we move to the next question? Okay, let's have a look. The question is, a water sprinkler in a garden can throw a water with speed u if sprinkler can arrange itself at required angle theta, find out maximum area in which water can be delivered by the sprinkler. By this sprinkler. That is what the requirement. Go through the question, है ना? Go through the question. Just think that what can I do, and what can be done, and what all has given. If something is missing, please go through the data one more time. You might get an idea. So first thing, what is the situation? A situation may be something like this, that let's say this is the water sprinkler that can be arranged with horizontal by making an angle theta, and from here let's say water can be delivered like this. Yes, with certain speed u that they have given, and this water sprinkler is going to rotate like this. This water sprinkler is going to rotate like this in a certain, maybe in clockwise direction, maybe in anti-clockwise direction, and it can cover the whole ground. So if you understand the situation, this could be the range. I hope this can be seen by you. This is the range. This is the maximum horizontal distance that can be traveled by a water. This is the maximum horizontal distance, and if it is a maximum horizontal distance that can be traveled, what you required is find out the maximum area. Basically it is a circle, and the area of this circle, it is equals to pi into r square. Here the radius will be the maximum range. Here the radius will be the maximum range. So what you need to do is, this area is equals to pi into r square. Now this is pi multiplied by range square. Now one more thing, I required that my area should be maximum. So if I require this, that my area should be maximum, that means my pi multiplied by range whole square, this range even should be a maximum. Yes, so my range is u square sine 2 theta by g. Maximum range when sine 2 theta equals to 1, so it is a u square by g. So this is equals to pi multiplied by u to the power 4 divided by g square. In this area, water sprinkler can deliver the water. This is the area, or we can say this is the scope at which water can be delivered by the sprinkler. Yes, did you get this? Did you? So can it be done? Can it be done? Are you sure? Are you sure? Is it possible by you guys? Are you sure? Can it be? Okay, let's move to the next question. The question is that if an object is being projected with speed u while making an angle theta with the horizontal, angle theta with the horizontal, find out minimum kinetic energy, of an object. I am going to add something here, but first you focus on this only, that what should be the minimum kinetic energy of an object throughout the journey of a projectile. What would be the minimum kinetic energy? That is what I require. So if I observe the situation very carefully, go through the data, an object is there, it has been projected with speed u and it is making an angle theta with the horizontal. I need to find out the minimum kinetic energy of an object. So the situation is something like this. This is u, this is angle theta, this would be the y-axis and this would be the x-axis. So what can you do? Or where kinetic energy would be minimum? What I know is, for kinetic energy to be minimum, velocity should be minimum. Yes, do you agree with me? Yes, when you require that kinetic energy should be minimum, that means velocity should be minimum. Where velocity would be minimum? At h max. So at h max, velocity will be minimum. And what is it? What would be the velocity at h max? Yes, it is u cos theta. It is the u cos theta at h max. So this kinetic energy is equals to half into m into v square. That should be is equals to 1 by 2 multiplied by m multiplied by v square. This is u square cos square theta. This is half into m into u square cos square theta. Yes, that's it. This is the minimum kinetic energy of a projectile in its journey. Yes. Next application. Second, find out change in momentum when projectile completes its journey. I need to find out the change in momentum when projectile completes its journey. So the situation is something like this, that this is the beginning of the journey, and if it is a beginning of the journey, this will be the u cos theta I cap, this will be the u sin theta j cap. This is the ending of the journey. This is u cos theta, because I know at the same horizontal point velocity would remain the same. This is u sin theta. So if I write v initial and v final, my v initial should be is equals to u cos theta I cap plus u sin theta j cap. Yes, this is the initial and this is the final. My v final should be is equals to u cos theta I cap, but here it is moving in this direction, so this would be minus of u sin theta j cap. Now what I want change in momentum. It is equals to m multiplied by vf minus of vi. So if I execute this vf minus vi, then it would be an u cos theta I cap minus of u sin theta j cap minus of u cos theta I cap minus of u sin theta j cap. So this plus u cos theta I cap minus u cos theta I cap has been gone, and this delta p that would be equals to minus of 2 into m into u sin theta j cap. This is change in momentum. If they require in magnitude, then have a value that is positive in it. It's a delta p that is equals to minus of 2 into m into u into sine of theta. I hope this is clear. Is it clear? Is it clear? Yes, great work. So let's wind it up this lecture here. Yes, so I have tried to cover many of the applications, but these are not limited. Yes, I hope you understand this. So please practice as many questions as possible. Revise these 3 sessions. It's a projectile motion 1, projectile motion part 2, projectile motion part 2. As well as I request you people to please revise vectors as well. Yes, so please revise them. Make practice of these questions, as many questions as you can do. Please do it. Yes, have a good day. Take care. Bye bye.